Okay, this is lesson 10.4. We're going to talk about computing scientific notation with multiplication. You may have guessed that we'll also be computing scientific notation with division, but that'll be a lesson for probably tomorrow. We are going to go over the warm-up, so please pause the video, do the warm-ups, and then start the video again. Okay. The first thing I like to do is if I don't have an exponent written, I like to write the exponent. So I'm going to put -4 to the first power. I am going to distribute my -3 to all of the exponents. Okay? So I get -4 raised to the -3rd power. I covered up the negative, but it is a negative. X raised to the -6th power. Y raised to the -15th power. Now, I cannot have negative exponents. I can't do anything with them. This is all over 1. So I have to, any negative exponents have to take the reciprocal. So I have to move the negative exponents to the bottom. Well, that's just about all of them. But it is all of them. So I get -4 to the 3rd power, x to the 6th power, y to the 15th power. Now, it's all done except I need to simplify the -4 to the 3rd power. Whenever you have an exponent, please put the number in parentheses in your calculator. So, -4 times -4 times -4 equals 1 over -64 x to the 6th power, y to the 15th power. Okay? This one I have to multiply all of the exponents by -6. And what didn't I do first? I didn't write in my 1s. That's raised to the 1 power. That's raised to the 1st power. So this gives me x to the -18th power times y to the -6th power all over x to the -6th power. Anything that's negative, I have to take the reciprocal. So x to the 6th power needs to move up. X to the 18th power moves down. Y to the 6th power moves down. Now, I have 6 x's on top, 8 x's on bottom. I move the smaller number to the bigger number and make it the opposite sign. So I'm going to move down my 6. It becomes negative. So that means everything up top is gone. 18 minus 6 leaves me x to the 12th power, y to the 6th power. We're not going to go over number 3, but you are responsible for having it done. Okay. When numbers are very big or very small, we write them in scientific notation. I'm going to write this expression and convert it into decimal form. So here is how we convert scientific notation back into decimal form. This right here, this is scientific notation. You have a number, the decimal is in between the first two numbers, times 10 to some power. That's how you write scientific notation. Now, in order for it to be in decimal form, the decimal has to be moved to the end. If the decimal is on the end, then I need to move it in between the first two. However, if I'm converting out of decimal form, scientific notation into decimal form, this tells me to move the decimal point to the right. How many spaces? 2 places. I know it's to the right because this 2 is positive. Okay? This 3 is negative, so I'm going to move the decimal to the left. How many places? 3. So I move number 2 to the right, 2 places. I move number 4 to the left, 5 places. So if your exponent is negative, you move to the left. If it's positive, you move to the right. This is what it would look like. I'm going to move this right here to the right 2 places. 1, 2. So that means my new answer is, or my decimal form is 284.2. When I move it out of, you don't have to do that. When I move it out of scientific notation, I drop off the times 10 to the something power. If I move it to the left, I move this to the left, 1, 2, 3 spaces, I need to add 2 zeros, 0.006392. That is the decimal form of 6.392 times 10 to the negative power. Okay? Negative fifth power. I'm sorry. Thank you for pointing out my mistake. I was looking at the circled one. You're right. I do, because it's to the fifth power, I have to move it 5 spaces to the left. So 1, 2, 3, 4, 5, which means I need to fill in 1, 2, 3, 4 zeros. So it's 1, 2, 3, 4, 6392. That is my decimal form. Okay. I confused these two numbers. All right, here we go. Now, we're going to convert the following into scientific notation. So please pay attention. I have a very easy way. If you do the easy way, you have no problems. So here we go. In number 5, where is my decimal if I don't see one? What? Yep, if you don't see a decimal, it's behind the last number. It's just there, understood, if you don't see a decimal, okay? Now, for scientific notation, where does my decimal have to move to? What? No, where does it have to be? Where do I have to have my decimal in scientific notation? Between what two numbers? Where do I have to have my decimal? Here, look over here. This is in scientific notation. Look at all of these. Where's my decimal and all these scientific notations? Between what? Well, that's just because of this number, but tell me where it is without using words like hundreds and thousands. Where is my decimal? In between the first and second number, thank you. I have to move it in between the first and second number. So, number 5, what's the first and second number? Has to move between the 5 and the 4. I make an X there. X marks the spot. Make an X between the 5 and the 4. I always, when I'm converting the scientific notation, I always move from the X to the decimal. Always move from the X to the decimal. How many spaces do I have to move, kids? 1, 2, 3, 4. So, I write 5.4236 times 10. How many spaces did I move? The fourth power. Did I move right or left? I moved to the right. When you think of the number line, is to the right positive or negative? Positive. So if you move to the right, this 4 is positive. Let's look at number 7. Number 7, my decimal is here. Where does my decimal have to be for scientific notation? Between the... Right, so between what two numbers here? The 5 and the 2. It has to be to the right of the first number. These are all zeros. They don't count as numbers. They're just placeholders. So it has to be between the 5 and the 2. So now I move from the X and I go to the decimal. So, but wait, first what I'm going to do is I'm going to write 5.2 times 10. I'm not going to put in my exponent yet. See how I converted my X to the decimal over here? Now I move from the X to the decimal. How many am I going to move? 1, 2, 3. I move 3 spaces. So this becomes a 3. However, which way did I go, left or right? So this becomes a negative 3. Very good. Okay, pause the video, do 6 and 8, and then start the video back up again. Okay, let's look at number 8. Number 8. What happened? Hello, what happened? I know my decimal is right here, okay? I need my decimal to be between the 8 and the 2. Now, sometimes kids think, oh, it was at the comma, so now it's always going to have to be at the comma. No. No, 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 no. It has to be between the first 2 numbers. So now I move from the x to the decimal. How many am I going to move? 1, 2, 3. So this equals 8.2 8.231 times 10. How many times did I move it? To the third. Did I move right or left? So it stays positive. Okay. Now, it has to be between the first 2 numbers. 0 is not a number. 0 is simply a placeholder. So the first 2 numbers is 1 and 2. So it has to be between the 1 and the 2. Okay? So I'm going to write this 1.2 times 10. What happened to all my zeros? They're just placeholders. They drop off. So now I need to move from the x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. I move to the left, so it's negative 10. Okay? Now, let's get on to today's lesson. That's not even what today's lesson is. That's something you should have known. That was just a quick review. Today's lesson, we are going to multiply square roots. Sorry. We're going to multiply scientific notation. So, guys, right here are your notes. If you're going to college, you're going to have to understand what this says right here and then be able to apply it. That's what they do in college. They give some lecture, they tell you to read a bunch of stuff, and then they expect you to come in and be able to do what you heard and read. So, you're going to have to develop the ability to read your directions and your notes and then apply it. Okay? Here's what it says. Multiply the coefficients to get the new coefficient. When it says coefficient, they mean the numbers in front of your x. Okay? Oops. So, multiply the new coefficients. Multiply the coefficients to get your new coefficient. Add the exponents. Watch the signs to get the new exponent. Get the number into standard form if needed. Okay, so here my coefficients are 4 and 2. I'm just going to say add the numbers in front of the x. Even though that's not an x, I know it means times, but I want to talk in language you can understand. So here I'm multiplying my 4 and my 2, and I get 8. Okay? Now I'm going to add my exponents because what's the rule? When we add like bases, what do we do with the exponents? You add them, yes. This is 10, this is 10. I'm multiplying like bases, so all I do is add the exponents. Right here are my adding the exponents. Now, 3 plus 7 is 10. There's my 10. That's my answer. Here is the exception. In scientific notation, you can have a negative exponent because it's telling you where to move the decimal. This is the only time you can have a negative exponent. Let's look at example 2. 2 times 5.5 gives me 11. Negative 5 plus 8 is 3. However, 11 is not in scientific notation, is it? It's not in scientific notation until you have a decimal in between the first two numbers. So, I take 11 times 10 to the third power. I put an X where my decimal should be. My decimal on this one is right here. My decimal, when I don't see one, is behind all of the numbers. And I move from the X to the decimal. I moved 1. So I have 1.1. Notice how I'm replacing the X with the decimal. Times 10. I moved 1 to the right. So what do I do with my 3? Plus 1. That's how I got to the fourth power. I moved 1 to the right. That means I plus 1. Okay, let's see a couple of these in action. Here we go. Here's how this works. 5 times 2.6. What's 5 times 2.6?
13.
So this gives me 13 times 10. What's 5 plus 3? 8. Is 13 in scientific notation? No. Where does the decimal have to be? In between the 1 and the 3. Where is the decimal in 13 when I don't see one? Right here. Start from the X. X marks the spot. I go from the X to the decimal. How many did I move? Did I move to the right or left? Plus 1. My answer is 1.3 times 10 to the 9th power. I'm going to show you one more example, example number 8. And then you're going to work on these and ask any questions. You guys who are watching these, if you have questions, you got to come in, man. This is not pow pow. You cannot use pow pow and get your answer. You have to write it out. 4.3 times 10 to the third power times 4.3 times 10 to the third power. 4.3 times 4.3 is? Oh, hit your SD button. 18.49 times 10. What am I going to do with my two 3's? They're exponents. What do I do with them? What do I do with them? Add them. Or tom them. I don't care. You can add them or tom them. 3 plus 3 is? Is that my answer? Is that my answer?
No.
No. This isn't in scientific notation. Where's my decimal?
It's not in between.
It's not in between the 1 and the 8, so I have to put an X here. So I have to write 1.849 times 10. I don't know what it is yet. I move from the X to the decimal. How many did I move?
1.
Did I go right or left? Plus 1. There's my answer. Okay? You guys want to do one more? Number 4. Okay. So I'm going to multiply the numbers in front of the X. So, what is 8 times 4.3? What?
34.
Whoa, I got two different answers now. 4 times 8.3 equals 33.2 is the answer. Times 10. Now, all I do is I put these numbers in the calculator. And I can even go, if I want, 6 plus minus 7 equals, what does it tell you? What? -1. Very good. Now, is my decimal in the right spot? No, it needs to be behind the first number, to the right of the first number, so I got to put it here. So I'm going to have 3 3.32 times 10. How many am I going to move? 1. Which way am I going to go?
Right.
To the right. So that means I have to do what with this negative 1? Plus 1. Negative 1 plus 1 is 0. Oops, that's a mess. Okay, now, I've already told you anything raised to the 0 power is 1. If you leave it like this on the test, I'll accept it. That's fine. So 10 to the first power is, 10 to the 0 power is really what? What's 3.32 times 1? That's your answer, 3.32. You don't have to write 3.32. You can write 3.32 times 10 to the 0 power. That's okay.
Oh, so you don't have to solve it.
I'm not going to require you to simplify that. This will be fine, okay? Okay, ladies and gentlemen, do you know what the number one complaint of employers is about workers who are in high school or just out of high school? Number one complaint. Do you know what it is? They cannot think for themselves. You give them a problem that is similar to how they were trained, and if it's not exactly like how they were trained, they can't adapt. They can't figure it out. Math solves that problem for you. Now, I hadn't shown you anything like number 4 before. However, I have taught you everything you need to do number 4. You just have to adapt. Okay? All right, if you have any questions online, please come in and ask. Have a great day.